So far in this chapter, we have been getting more and more specific. We started off with polygons, then we went to special types of polygons that have four sides called quadrilaterals. Then we went to special kinds of quadrilaterals that have parallel sides called parallelogram. Then we went to special kind of parallelogram called a rectangle. Well, today we're going to do a special kind of rectangle called a square, as well as another figure called a rhombus. So let's see what the properties of those two are that make them different from the other figures that we have studied so far. A rhombus is a parallelogram, but it has four congruent sides. Okay, so all four sides are congruent. Notice that the angles are not necessarily congruent, just the four sides. Now, since a rhombus is a parallelogram, it's going to have all the properties of the parallelogram. We are not going to take the time to go through those. Again, we've gone through them several times. You should know those properties by now. Because it's a parallelogram, it's also a quadrilateral. So it's going to have all the properties of a quadrilateral. Any group that it's in, it's going to have those properties. Okay, so its diagonals are going to bisect each other. The sides are going to be parallel. Okay, those kinds of things. Again, we're not going to go through all those. So what is new about a rhombus? Well, a rhombus has diagonals that are perpendicular. Okay, so here's a new relationship here. Because they're perpendicular, we know that they make that right angle. So we can solve for some unknown measurements there, knowing that they're going to equal 90 degrees. And then the converse is also true. If the diagonals of a parallelogram are perpendicular, then we know that parallelogram is a rhombus. So these two are saying the same thing, just backwards. The second property that makes it different is that each diagonal of a rhombus bisects the pair of opposite angles. So we know those angles now are being cut in half. Remember, that's what bisect means. So again, because we know that relationship there, we might be able to solve for some unknown parts. Okay, so know those two differences. These are the two properties that make a rhombus, as opposed to any other parallelogram. Okay, so here's what a rhombus is going to look like. All four of these sides are congruent to each other. I'm going to put 3 congruency marks here to distinguish them from the diagonal parts. Okay, so we have our 2 diagonals that bisect each other. We know that because of these congruency marks, the same on both parts. Notice that they are forming a right angle here. They are perpendicular to each other. They also have bisected these opposite angles. So all 4 of these parts are the same, as well as these 2 pair of opposite angles. They've been bisected so that their parts are all the same. Do you remember what the relationship is between these consecutive angles? If this is a parallelogram, these consecutive angles are supplementary. Okay, so we could do something here like, okay, if I know that this is, oh, I don't know, let's make this 50 degrees here. Okay, this part right here is 50 degrees. What is this angle? Okay, well, if I know this is 50, I know this is 50. So together they're going to be 100. And since these are consecutive angles, they have to be supplementary. If this is 100, this has to be 80. This whole big angle has to be 80. So what would these individual angles be? 40 and 40. So that's an example of how you would use these relationships to find some missing parts. Okay, let's do another one. We're trying to find y if angle 1 is y squared minus 54. Okay, that square, don't let that freak you out. Let's just work the problem the way we know it and see what happens. So if angle 1 is y squared minus 54, and I look here and I see that this is angle 1 right here, what do I know about the measure of that angle 1? Because this is a rhombus and these diagonals are perpendicular, I know that they make a right angle. So I can set this equal to 90 degrees. Okay, so let's just work the problem and see what happens. Don't freak out, just do what you know needs to be done. And then if you get stuck somewhere along the way, we'll talk about it. So when I add 90 to 54, I get 144. So y squared, that means some number times itself is 144. So you might be able to just figure that out by me saying it that way. What number times itself is 144? Or you could remember your algebra. To undo squaring of something, you have to take the square root of it. What I do to one side of my equal sign, I have to do to the other side. So the square root of y squared is just y, whatever's inside here. The square root you could do on a calculator, or you might know the square root of 144 is 12. Okay, so it worked out just fine. That squared y didn't really put a kink in things at all. Okay, whoops. Let's do another one. Use rhombus LMNP to find the measure of angle PNL. PNL is right here. So I have to mark it. I have to look at this to see the relationship so I know what I'm talking about. If MLP, this whole thing, is 64. Okay, well, I really shouldn't even have to work anything out. I know that my opposite angles are going to be congruent. And then I know that these diagonals bisect the opposite angles. So if this whole thing is 64 over here and it's bisected, then this is going to be 32. Okay, but I needed to know that relationship. I needed to know that it was bisected. Okay. Excuse me. One more. Use rhombus ABCD and the given information to find the value of each variable. Okay, well, it's kind of cut off there, but it says that the measure of angle 1 here is 2x squared minus 38. 2x squared minus 38. Well, because this is a rhombus, I know that this central angle here is going to be 90 degrees. So 2x squared is going to equal 128. Again, don't let this squared freak you out. Let's work the problem. If I divide by 2, x squared equals 64. Now, what is the square root of 64? What times itself gives us 64? 8. But remember, the negative form of that could also give us 64 because a negative times a negative is a positive. So don't rush through and pick choice A. Think about it. Take your time and think about each answer choice because the correct one here is D. Okay, we have the rhombus again. Find the value of each variable. So if CDB, this little angle right here, is what we're trying to find. If ABC, this whole big angle here is 126. So what are we going to do to find this part? We're going to cut it in half, so that's 63, which is answer choice B. Okay? Now, that's the rhombus. On to the next shape, which is the square. A square is a quadrilateral, just like the rhombus was, and it has 4 congruent sides, just like the rhombus did. But it also has 4 right angles, like a rectangle. So a square is like putting a rhombus and a rectangle together. It's like putting a rhombus and a rectangle together. It has the properties of both. So it is a rectangle and it is a rhombus. Because it has the properties of both, it is both. It is also a parallelogram. Okay, and it's also a quadrilateral. It has the properties of all of them. So here's what a square would look like, all marked up. All 4 sides are the same. We actually should even put parallel markings in here because the opposite sides are parallel. Our opposite angles are bisecting each other and they are also congruent. Every property that we have learned so far applies to the square. It's special. Okay, so we have rectangles that are parallelograms, we have rhombi that are parallelograms, and we have squares that are all of those things. And then above a parallelogram, remember, we have quadrilateral, and above that we have polygon. Kind of a flow chart. Okay, so know these relationships here. We're going to add to them with a couple of other things and then we'll be finished.